In a world dominated by automation, sensors, and instant optimization, some systems continue to operate on principles far older and in many ways, far wiser. Hidden deep in Oregon stands a working industrial monument that refuses to be replaced. Before any wheel turns, the journey begins in the Pacific Northwest forest. Here, Douglas fir, hemlock, and cedar rise to extraordinary heights, some growing for more than a century before meeting a saw. These trees are not harvested casually. Their sheer mass demands careful planning, precise felling angles, and an understanding of wind, terrain, and internal stress. Unlike modern clear-cut systems, each tree is assessed individually. Loggers read the lean, feel the tension in the trunk, and choose cuts that protect both workers and surrounding forest. In this environment, nature does not forgive shortcuts. Once the tree falls, gravity becomes the next challenge. Steel-cabled yarders lift massive logs up steep slopes, threading them through the canopy with controlled momentum. The movement looks brutal, but every motion is calculated to minimize ground damage and preserve access routes. At the landing, the rhythm shifts. The forest silence gives way to the low thunder of Kenworth and Peterbilt logging trucks. Built for punishment, these machines haul loads exceeding 80,000 pounds across mud, inclines, and narrow mountain roads. Time matters. So does balance. One misjudged corner can end a career. Hull Oaks was built for timber modern mills avoid. Oversized logs, long beams, heavy structural wood. That specialization is what keeps this mill alive. When the trucks arrive, the logs do not enter the sawmill immediately. They wait floating in the log pond. This pond is not storage. It is preservation. Water slows moisture loss, prevents checking, and protects grain integrity. It is low-tech moisture control that outperforms many modern systems for massive timber. Here, pond monkeys take over. Veteran operators guide logs using poles and hooks, reading water movement, anticipating roll patterns, and preventing jams before they form. Their work is dangerous, demanding, and deeply skilled. Automation cannot replicate this intuition. Only experience teaches how weight, buoyancy, and momentum interact across dozens of floating logs. From the pond, logs rise into motion. Debarkers strip away thick outer bark, exposing clean wood while protecting saw blades from stone and grit. The bark does not become waste. It becomes mulch, boiler fuel, or energy feeding the steam system that powers the mill. This closed-loop operation is not marketing. It is survival. Crosscut saws prepare the logs for the heart of the operation. Then the carriage takes over. Mounted on steel rails, gripping logs with iron dogs, the carriage feeds timber into massive steam-driven bandsaws. This is where the sawyer commands the process. The first cut is everything. One decision determines yield, strength, and value. The bandsaw glides with minimal kerf loss, revealing grain instead of destroying it. Slabs peel away and are immediately repurposed. The log shrinks, becomes squared, then becomes lumber. Boards flow through resaws, edgers, and trimmers. Cracks removed, edges squared, defects eliminated. Unlike fully automated mills, inspection here is tactile. Workers touch grain, listen to tone, and judge flexibility by hand. Quality is sensed, not scanned. Some logs never become boards. Massive Douglas fir trunks remain intact to serve as bridge beams, railroad timbers, and restoration materials. These giants meet circular saws designed purely for force and stability. Moving them requires overhead cranes. Steel cables lift tens of thousands of pounds with smooth precision. This is technology amplifying human ability, not replacing it. Behind the noise lies the filing room, the mill's silent heart. Here, bandsaw blades nearly 50 feet long are sharpened, tensioned, and balanced by hand. A single flaw can cause wobble, crooked cuts, or catastrophic failure. Sharpening is mathematics. Tensioning is art. This knowledge is passed down, not downloaded. When a blade returns to service, the mill breathes again. Cleaner cuts, less waste, greater safety. When the day ends, lumber is stacked ready for construction, infrastructure, and craftsmanship across America. Each beam carries more than wood. It carries time, labor, and restraint. Hull Oaks is not fast. It is not optimized by software, but it is efficient in a deeper sense. Every log is respected. Every byproduct is reused. Every decision has weight. This is green technology before the label existed, where sustainability is enforced by material limits, human skill, and accountability. Steam still turns wheels, steel still sings, and history continues to work.